Let's deal with a more complicated example of multiplying fractions. Notice now we have more complicated terms and two fractions to deal with, and so our first move is going to be to factor everything as much as we can. Let's begin with the first expression, x squared minus 4x. This is a binomial. When we have binomials, we will look for common terms. Here we have no numbers in common, but they both do contain x, so we can pull that x to the outside. Then on the inside, we will divide both of these terms by x. X squared divided by x gives us just x, and negative 4x divided by x gives us negative 4. This will be the factored form for the first term. For the term underneath it, we'll have x squared minus 4x plus 3, which is a trinomial. For this trinomial, we will try to split it into two parentheses. Notice that our c term for this trinomial is positive 3, and the only way we can get 3 as the c term is by doing 3 times 1. But if we now take 3 plus 1, this will give us positive 4. That is the wrong sign for this example, so we'll change both of the signs and have negative 3 minus 1 equals negative 4. That's a match. Therefore, our new parentheses is now x minus 3, x minus 1. Now we'll move on to the top of the second fraction, x squared minus 1. This is a binomial, but you may notice that x squared and 1 are both perfect squares. If you have a binomial that contains only perfect squares and a negative in between, this is now a difference of squares, which is one of our special forms. Therefore, we know in our two parentheses we'll have x in the first position and the square root of 1 in the second position. But the square root of 1 is still 1. So we'll have x plus 1 and x minus 1 according to our formula for the difference of squares. This will be the factored form of our third piece of the fractions. For our fourth piece, we'll have x squared minus 3x minus 4. This is another trinomial, and so we can expect two parentheses. This time we're going to multiply two numbers to make negative 4. To get negative 4, there are two ways we could get that. For negative 4, we could try negative 4 and positive 1, because if you multiply them together, they'll make negative 4, or negative 2 and positive 2. If we tried negative 2 plus 2, that would give us 0. That is not a match for our middle term. So we'll take negative 4 plus 1, and that gives us negative 3. That's a match. So inside of those two parentheses, we'll have x minus 4, x plus 1. This will be our fourth piece. Now, we'll replace our original binomials and trinomials by these factored forms. When we rewrite these fractions, we'll have x times x minus 4 on the top of the first fraction, x minus 3, x minus 1 on the bottom of that first fraction. Multiply on top now by x plus 1, x minus 1, and divide on the bottom by x minus 4, x plus 1. When we multiply, we can combine these two fractions into one very big fraction. And so on top we will have x times x minus 4 times x plus 1 times x minus 1. On the bottom we'll have x minus 3, x minus 1, x minus 4, x plus 4. Now that we have our big fraction, let's try to simplify this down. If we look on top and bottom, we will see we have an x minus 4. Both of those will cancel when we divide them. We also have x minus 1, which we can cross out as well. Nothing else will cancel because we have no exact matches. And it's important to realize that this monomial x in the front will not cancel with either of the binomials on the bottom. The reason for this is because they have different numbers of terms. The only way you can cancel a binomial is by having exactly the same binomial. For the same reason, the only way we can cancel that monomial x is by having another monomial x. A binomial x will not fit. Therefore, our simplified form of this fraction will be x times x plus 1 on top and x minus 3 times x plus 4 on the bottom. We can stop at this point because that monomial x will not cancel with anything, and we have no binomials left that can cancel.